before I get into these notes for 11.8, this is the first video I'm recording for you guys, and I just want to say, like, I'm gonna miss this class. You were wonderful, and I hope you know I'm not saying this to, like, pretty much any other classes. This was a wonderful class, and this will be missed. So I hope all of you are doing well and safe, and you're not going crazy, stuck indoors, okay? Alright, 11.8, combinations. Yes, I'm sick. A combination is a distinct group or set of objects without regard to their arrangement. The number of combinations possible when R objects are selected from N objects is found by combination formula. So our formula is NCR equals the factorial of N over N minus R factorial, R factorial. N is the total number of things you can select. R is how many selections are you actually making. So example 1, let's identify if it's a permutation or a combination. A group of 5 friends are forming a club. The group will elect a president and a treasurer. And how many different ways can the president and treasurer be selected? So since the president's position is different from being the treasurer, we have a permutation problem. Hank as president and Peggy as treasurer is different than Peggy as president and Hank as treasurer. The order of the selection matters. So there, the order matters because if Hank is president, Peggy can't be president, and vice versa. So that's a permutation. Permutation order matters. Of 5 friends, 2 will be attending a meeting together, and how many ways can they do so? So there is no difference if Hank is selected or Hank is selected and then Peggy is selected, or vice versa. Since the order in which 2 individuals selected to attend the meeting is not important, we have a combination problem. So if you're going to a meeting, does it matter who goes in first or who attends first? It doesn't. We're all there, right? The order doesn't matter. We're all just there sitting in the meeting. So that would be a combination problem. Combination order does not matter. So book selection. Your American history class. In your American history class, you are assigned to read any 3 books from a list of 8 books. And how many ways can you select 3 of the 8 books to read? So for here, it's combination because if you read one book, you just read the next, right? Order doesn't matter. If I read one of the books, it's not going to affect any way the other reading material. So since we have a combination formula or problem, we're going to use our formula NCR equals factorial of N over N minus R factorial, R factorial. Our N is how many total books can we pick? We have a total of 8 books to read. Our R is how many we're actually picking. We can read 3 of those 8 books. All right, so remember factorial is, well, let's simplify that denominator first, because we can do the 8 minus 3, which is 5. So remember, factorial is 8 times 7 times 6 times 5 times 3 times 2 times 1, all the way down. But we don't need the 1. So 8 times 7 times 6 times 5 times 3 times 2. And on the bottom, for our 5, we have 5 times 4 times 3 times 2. And for our 3, we have times 3 times 2. You don't need the 1. So let's start canceling out everything that they have in common. They have a 5 in common. They have a 3 in common. They have a 2 in common. I'll run out of colors here. And then they also have, I don't know if you see it though, so it's okay, let's just keep going. So let's simplify. You can cancel out a couple more things, but if you don't see it, that's fine. Like the 4 and the 2, that's 8, so we could actually cancel out the 8 and the 4 and the 2. But if you can't see that, that's fine. Let's just cancel out exactly what's the same. So we have 8 times 7 times 6 on top, which is 336. And on the bottom, we have 4 times 2 times 3, and that's 24. We're going to simplify our fraction, so 336 divided by 24, and we get 14. That's wrong. What'd I miss? I see where I messed up. Going to erase all this and start over again. I'm not editing my videos, so that's why I would normally just edit them and go back, but I'm not editing my videos, so I forgot the 4. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2. And on the bottom we have 5 times 4 times 3 times 2. And then 3 times 2. My bad. Alright. Repeat. Let's do this again. So we can cancel out the 5. We can cancel out the 4. We can cancel out the 3. And we can cancel out the 2. So on top, we have 8 times 7 times 6, which is 336. And on the bottom, we have 3 times 2, which is 6. And 336 divided by 6, we get 56. So there's 56 different combinations that you can read this book, or these books, in selection. Alright, you're going to hear my dogs bark as I make these videos. So Jan has 10 different photos for which she will choose 6 to hang on a wall. How many different ways can she do so? So we're not caring about an order here. She just wants to hang some pictures, right? I am referencing the dinner party episode. If you know, you know. All right, so our N is how many total, which is 10. And our R is how many that she wants to pick. So she wants to choose 6. So let's plug it into our formula. We have 10 factorial over 10 minus 6 and 6. So let's simplify our denominator. We have 10 on top, and then 10 minus 6 is 4. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And on the bottom, we have our 4 factorial, so 4 times 3 times 2. And then we have our 6 factorial, so 6 times 5 times 4 times 3 times 2. All right, we could do some canceling. We could do 6, 5, 4, 3, 2. There is more that you can cancel. If you see it, you see it. It's cool if you don't. So on top, we have 10 times 9 times 8 times 7. And that comes out to 5,040. And on the bottom, we have 4 times 3 times 2, which is 24. So 5,040 divided by 24, we get 210. So if she wanted to hang 6 out of 10 pictures, she can arrange them in 210 different ways. All right, last example. So at a local restaurant, dinner consists of selecting 3 items from menu or from column A, 4 items from column B, and 3 items from column C. Excuse me. If columns A, B, and C have 5, 7, and 6 items respectively, how many different dinner combinations are possible? So in column A, you select 3 out of 5. In column B, you select 4 out of 7. In column C, you select 3 out of 6. So that means we have 3 things going on here. We have column A picks, column B picks, and column C picks. So for column A, the total number of picks we can have is 5, and we're choosing 3 of them. So we plug them into our formula. So we have 5 on top, 5 minus 2, or my bad, 5 minus 3, and 3. Pretty sure you can get the hang of it now. You know how to plug it or work it out, and we get 10. Now we have to do the same thing to B. So in B, we have 7 things to choose from, but we're only picking 4. So we have 7C4. So 7 7 minus 4, and 4, which comes out to 35. Now, for the C column, we have 6 things to choose from, but we can only pick 3. So we have 6C3. So 6 on top, 6 minus 3, and 3. When we simplify that, it's 20. So we pick something from each column. So since we pick something from every single column, we need to multiply all these numbers. So 10 times 35 times 20, and we get 7,000 different dinner combinations. This little chart here is to help kind of distinguish in a better way the difference between permutation and combination. You can definitely read it on your own. There's nothing more I could say that isn't already on here. And to save my voice, I'm going to stop here.